Hi everybody. In today's episode we're going to talk about some basic differentiation rules or shortcuts to using the formal definition of a derivative that we have been using in prior episodes to find our derivatives. Before we talk about our first couple differentiation rules, I want to talk more about derivative notation. So we've seen we can represent the derivative of f of x as f prime of x. Well, now, this is another way of saying f prime of x, the derivative with respect to x of f of x. And finally, if our function is defined as y, we can simply say y prime. Oh, and there's one more. Let me add one more in here. Another way, if our function is defined as y, we can call the derivative dy dx, the derivative of y with respect to x. Now our first couple of rules. The constant rule simply says that the derivative of any real number is 0. The general power rule says that the derivative of x to any power with a coefficient of a is equal to the power times the coefficient times x, and then we reduce the exponent by 1. Here are some examples of the power rule. Before we jump in, I do want to emphasize the idea of writing our terms in this form, a coefficient times x to some power. And that power might be negative, but write it in that form before beginning your differentiation. So, for example, this first one, the derivative of 3 over x. Well, I'm going to write that first as 3x to the negative 1. Now that allows me to easily find the derivative using the power rule. So negative 1 times 3, x, and then it's going to be to the negative 2 power. We're going to reduce that negative 1 power by 1. So that's negative 3. And you could write that like that as well. Next example, we have a radical function, the cube root of x squared. Well, we can write that with an exponent, so that would be x to the power over the root. So that allows us to come over here and do our derivative. So that's going to be the power times the coefficient of 1, x, and then we're going to take 2/3 minus 1, that's negative 1/3. So we could write that as 2 over 3 to the cube root of x. Our next example, 3t cubed over 5. We can pull a coefficient of 3/5 out of that and use the power rule. 3 times 3/5, so 3 times 3/5 t, and we're going to reduce the power of 3 by 1. So that's 9/5 t squared. And finally, 2 root x. We can write that as 2x to the 1/2 power. And then using the power rule, once again, 1/2 times 2, x, and then 1/2 minus 1, that's going to be negative 1/2. So that's going to be 1 over the square root of x. And don't worry about rationalizing your denominators in AP calculus. They are fine with radicals in the denominator. Next, we're going to talk about the sum and difference rules. So the sum and difference rules simply say that if you have a series of terms defined in terms of x that are connected by addition or subtraction, then the derivative is simply the derivative of each term connected by addition or subtraction. Here are some examples, and as I go through these examples, I'm going to remember I want to write my terms in this form of a coefficient times x to some power if possible to help with my differentiation. So our first example, I'm going to first rewrite. So I can write that first term as 3/4 x to the negative 2. And this third term I can write as 3/2 x to the 5th. So my derivative, now using the power rule, negative 2 times 3/4, that's negative 6/4 x to the negative 3. And then 15x squared, that's going to be 30x, the derivative of 15x squared. And finally, 5 times 3/2. It's going to be 15/2 times x to the 4th. Let's go ahead and simplify that. So this is negative 3 over 2x to the 3rd. And in our final example here, we're going to take the 4th root of x cubed. So that's just x to the 3 over 4. And then the next term I'm going to write as 1/2 x to the 3rd. And then minus 5x minus 2. And what's the derivative of that? So 3/4, x to the 3/4. That's going to be 3/4 x, and what's 3/4 minus 1? That's negative 1/4. And then my next term, 1/2 x cubed, 3 times 1/2, that's going to be 3/2 x squared, and then minus 5, and then the derivative of 2 is 0. So that's going to be 3 over 4. We could write that as the 4th root of x plus 3/2 x squared minus 5. Now we'll look at the sine and cosine rules. And just to give you a sense of how they work, let's take a look at sine, which is our blue curve, and some notable rates of change. First of all, let's look at everywhere sine has a horizontal tangent. So at all its minimums and maximums, it has a horizontal tangent where the derivative is 0. And notice wherever those horizontal tangents are, cosine is at 0. So the cosine curve matches the rate of change of the sine curve, at least at horizontal tangents. Well, you could also see that in places where sine appears to be moving down at a linear rate of -1, around there, cosine is -1. And in places where sine appears to be or approximating a curve of +1, sure enough, there's cosine with a +1. So you might have guessed by now the derivative of sine is cosine. The rate of change of sine at any point on the curve is cosine. And the derivative of cosine, in turn, is negative sine. Now let's look at some examples of our sine and cosine rules. First, 2/3 sine x. So that's going to be equal to 2/3, and then the derivative of sine x is cosine x. This next one, cosine x over 3, we're first going to write this as 1/3 cosine x, and then the derivative would be the 1/3 times the derivative of cosine x, which is negative sine x. All right, in our final example, we can go straight to the derivative. The derivative of x to the 4th, 4x to the 3rd, power rule, and then minus the derivative of sine x, which is cosine